Did you know that in the Tokyo 2020 Olympics, Japan made an innovation? You see, Japan wanted their Olympic medals to be environmentally friendly. The problem was that gold mining is extremely damaging to the environment, and Japan is a poor natural resources country. It has very little gold. But Japan has one thing in abundance: electronics, especially old mobile phones. And when I say abundance, I mean it. We are talking about nearly 80,000 tons of old electronics that the country collected from all over. Just think about that. It was a massive national effort. That is why the Tokyo 2020 Olympic medals were made from millions of old mobile phones and electronic waste. So how in the world did they pull that off? Well, in this explainer, we're going to break that down. We'll look at where the gold is hiding, how it's unlocked, the massive industrial machine that makes it all possible, and of course, the surprising economics behind the whole thing. Now, the question is, where exactly is gold found inside a mobile phone? You might be picturing little bits of gold dust just kind of mixed into the plastic. But, the reality is so much more precise, and honestly, a lot smarter. See, gold is only used where it is absolutely critical. Think of it like surgical placement. You'll find it concentrated on the printed circuit boards, the green brain of the phone. It's also used to plate all the little connectors and contact pins. Those are the points where different parts of the phone have to communicate perfectly without fail. It's even in the microscopic wires that bond the computer chips to the board. So it's not everywhere, but everywhere it is, it's doing a vital job.
Now the question is, why is gold used in mobile phones? And why not some other metal? Gold is super expensive, right? You'd think a cheaper metal like copper or aluminum could do the job. Well, not really. Not when you need absolute perfection on a microscopic scale. It really boils down to three key things. First, conductivity. Gold is a fantastic conductor of electricity, making sure signals get where they're going with almost no resistance. Second, and this is the big one, gold does not corrode. It doesn't rust. Other metals can tarnish over time, especially when they're exposed to air. That creates this tiny film that can just ruin an electrical connection. I mean, one speck of corrosion on a microconnector and your whole phone could just stop working. Gold? It just doesn't have that problem. Which brings us to number 3, reliability. Because it doesn't corrode, gold gives you an incredibly stable, long-lasting connection. In the world of microelectronics, that kind of reliability is everything.
Okay, so we know the gold is in there, and we get why it's so important. But this leads us to the most practical question of all. Now, the most important question is, can we extract gold from mobile circuits and sell it? I mean, is this just a cool science fact, or is it a real viable business? The answer is a simple and pretty loud yes. But, and this is a huge but, this isn't something you can do in your garage. This is a highly specialized, heavily regulated industrial operation. It's done by licensed facilities, a lot of them in Asia, that have the right technology. The whole business model only works because they process just massive, massive quantities of this stuff. We're talking about a legal, controlled industry. Definitely not a backyard science experiment. So, what does this whole industrial process actually look like? Well, now the question arises, how is gold actually extracted from mobile circuits? You might be thinking that the circuit is simply melted to extract gold. It makes sense, right? Just heat the whole thing up, the gold melts, and you pour it out. Easy. Well, it's not that simple. Actually, just melting it is about the worst thing you could do. A circuit board isn't a gold nugget. It's this incredibly complex sandwich of fiberglass, epoxy resins, plastics, copper, tin, and a dozen other metals all fused together, with our tiny bit of gold mixed in. If you just melted it, you'd get a toxic, messy sludge of mixed metals. It would make separating the gold even harder. So the real process has to be way more clever. The industrial method is far more sophisticated. Let's understand how it works. Welcome to the urban mining machine. The journey from a phone to a gold bar really happens in 4 main stages. It all starts with collection and dismantling. So phones get collected and then they're stripped down, mostly by hand. But why do it manually? Well, for one, you have to carefully remove things like lithium-ion batteries, which can be a huge fire hazard. The plastic cases and screens also come off, leaving you with the most valuable part, the circuit boards. Next up is mechanical processing. These boards are fed into giant shredders that just pulverize them into a coarse powder. Now, the point here isn't just to destroy them, right? It's to liberate all those little flakes of metal from the plastic they're stuck in, which leads perfectly into physical separation. Now you've got this mixed powder. Huge magnets pull out all the iron and steel. Other systems use things like vibration and density to separate the heavier metal bits from the lighter plastics. You're left with this concentrated, metal-rich powder. But that's still a mix. So how do you get the pure gold?
Well, that brings us to the final and most complex stage.
And that final stage is called refining. This is where the real science happens. Inside these sealed, controlled industrial plants, that metal concentrate goes through a series of sophisticated processes. These methods are designed to separate out each metal from the mix, one by one. They pull out the copper, then the silver, and finally they isolate the pure gold, which can then be melted down and cast into shiny bars. It's a really high-tech, controlled ending to what starts as a very physical process.
Okay, this all sounds like a massive amount of work. I mean, it's a huge, expensive, really complex operation. And that brings us to the economics of it. What's the actual payoff here?
Now, the most important question is, how much gold is actually found in a single mobile phone? We know it's a tiny amount, but just how tiny are we talking?
Get this, on average, a single smartphone has about 0.034 grams of gold. To put that in perspective, that's worth maybe a couple of bucks, at most. On its own, the gold in one phone is economically worthless. The cost to get it out would be way, way more than the value you'd get back. It's just not worth it.
So if a single phone contains so little gold, how do factories manage to extract gold in tons? How can this possibly be a profitable business?
The answer? The secret sauce is one thing: scale. Pure, massive scale. The business model isn't built on one phone, it's built on millions of them. So yeah, one phone is basically worthless. But a million phones, well, now you're talking about 34,000 grams of gold, which is worth millions of dollars. These factories make money because they use heavy machinery and automation to process just incredible volumes 24/7. And what's more, they don't just get the gold, they also pull out silver, palladium, copper, and other valuable metals from that very same powder. So it's the combined value of all those metals multiplied by the massive scale of the operation that turns a pile of junk phones into a real treasure chest.
So when you really think about it, the point of all this isn't just that your old mobile phone has some gold in it. The bigger idea here is that there are tons of things all around us, things we see as waste, that are actually way more valuable than we can even imagine. E-waste is just one amazing example of a resource that's been hiding in plain sight.
It really makes you wonder, doesn't it? What other waste is just sitting there, waiting for us to find the right way to unlock its value? That's a question we'll definitely be exploring in the future.